Watch folks, today we're solving 9 times 9 consecutive nights by Rain Man. The rule set is as follows. Normal Sudoku rules apply, thermometer rules, arrows, and consecutive nights. Here, every cell must be a chess nines move away from at least one cell whose value is either one higher or one lower than it. And I think for me, that's the most challenging rule. The other are quite simple. If you want to give it a shot, hit the first link in the description. Otherwise, just watch me solve this. I'm going to scroll down to have this in mind a little bit better. And very dominant is like this big thermometer where you have to put the lowest number and then go higher when you go to the tip. And what I do is pencil mark the lowest possible numbers in for each of the two long arms, at least. That obvious cannot be a one. That's better. And this is 9. Then the highest option that's possible. Yeah. So the left hand side is kind of restricted with only two possible digits. So 3, 4. And 3 digits on the right hand side. Let me double check. It can be 1, 2, 3, 4, 5, 6, 7, 9, 8, 7, 6, 5, 4. This cannot be a 3 then, because there's maximum numbers of 3. Okay. Maybe let's use this rule, the last one, immediately, consecutive nights. If we think about this cell, it's either 8 or 9. Let's just say 9 for now. Then one of those cells need to be one higher, which is not possible with 9, or one lower, which is 8. This one obviously can't be 8, so if that's a 9, this needs to be 8. If this is an 8, one of those two needs to be 7 or 9. This one is out again, so that is a 7 or 9. And we have a triple here, giving us 6, 5, 4, 3, 2, 1, and ruling out here quite a bit. 6, 7. Now we have a pair here, giving us the 7 here. And this is 1, 2, 3, not 3 in here. So this could be 1 and 2, giving us a 3 in here. Can be 1 and 3, giving us a 4, or 2 and 3, giving us a 5. No more options there. And that's like a nice triple of those. Can we do the same on this side? 8 and 9 needs to pair up with 7, 8, 9 in one of those. Yeah, so if that's a 9, This has to be an 8. That's an 8. It could see this 7, or maybe a 7 in here, or 9 in here. No 9 in here, of course. And we have already by Sudoku 6 on the arrows. So we just figured out that there is a 7. That's at least 7 on the arrows. Okay, maybe let's have a look at this 7 because it can't be one up, down here, here. So it has to be one up or down here. The 6 is already covered, so that's an 8 pointing in this direction. 4, 3, giving us a 9 there. Is that valid? Yeah, because if the 9 is here, we need to have an 8 in here, which is not true. Going down to the left-hand side, solving this. Okay, 5. 5 is a 3 and 2. No other option there. So 2 and 3 giving us the 1 in here. And we have the first box solved. Okay. If we have a look at this one, that's not +1 or 2. +1 or -1, that not. So this needs to be a 2 because 1 can't be -1. So we are missing a 1 in this row and I think 4. 1, 4. Okay, but other than that, I don't think that that helps. Like if you have a look, 3 does have a pair already here. 2, no, no, maybe, maybe. Don't know that for sure. Oh yeah, yeah, we do know that for sure because look at this cell. It needs to be 1 up here or 3 up here. So it is this cell and the 1 is also occupied. So that's a 3. Okay. Maybe have a look at this box. We still need a 1. Can go in here. We still need 2. Can only go in here. 3 is the same, so that's a pair. Right, yeah, that's a pair. So that's a 1 and 4 pair, but a 4 is already here, so that's a 1, that's a 4. Otherwise, we would have had 6 here. It's already taken. We have a 9, so we need the 4 to be in there in the arrow to get to 9. What pair is missing here? 7, 9. And to complete the box, it's 4, 5, 6. It's an entropy, middle entropy. Okay. Can this be a 3? No, it can't, because 3 needs to see 2 or 4 in one of those cells. But it's only 1, so that's the 2, and that's the 3. Okay. Looking good so far. A lot of pencil marks in the box, but it's nearly done. Does the consecutive night rule still apply? Maybe let me color in the one that do apply. 7 sees the 8, 1 sees the 2, 3 sees the 2, 2 sees the 1, 8 sees that with something light, maybe green. 3 sees the 4, 6 sees the 5, 3 sees this 2, 2 sees 3. Okay, that's already this 3 sees this 2. Quite a bit, which is nice. Okay, let's have a look at this. If that is a 5, we need to have 4 or 6 in one of those cells, which we have not. So no 5 in here. 4 and 6 would be possible because that sees this 5. If we have a 4 in here, we need 3 or 5 in here, which is not possible. So no 4 in here. 5 is possible because it sees a 4, and 6 because the 6 is not possible in here because it doesn't see it could see this 7. Okay, check this also. 4 is possible because of the 5, like 6, and 5 is possible because of the 4. Yeah, okay. Helped a little bit, not much. We could add a little bit of messy pencil marking. It's like this and like this. Maybe let's have a look at this. It needs to be at least 2 and like 2 and 4, which is 6. It's a minimum amount we put in. 6 is already there, so it's a 7, 8, 9. We cannot have an 8 in here. Because we should need a 1 to get to 9 then. That's very vague. Okay. Let's have a look at this 7. We need a 6 or an 8. Only free cell is this one. 6 is already there, so it's 8. No 8 in this cell. And those see each other. Which validates both for this. Could both be. How to get to 7? We can use a 2 in here. And then a 5 in here. 1, 2, can use a 4 and a 3, no. And 6, 1 is also not possible. So 5 and 2 is surprisingly the only option to get to 7 in here. how to get to 9. 1 and 8 is out. 2 and 7. Again, 2 needs to be here, then 7 needs to be here. 3 is out. 4 and 5 can't be because this can't be 4 and 5. And that's it. That means this has to be a 2, right? Yeah, yeah. Because otherwise, to think about it, we have 1, 3, 4, 5 looking at it. So minimum is 6. We can't use the 1, 4, 7 and can't use the 3 to 9. So that is our 2, which doesn't see any other cell yet. Mm. We can try to have a look at this arrow and messy pencil mark here. It needs to be at least a 2 is already on top. 3, so 4. 8 is taken. 9. That can be 3, 6, 7, and 8. And 1, 4, 5, 6, 7. Can't be an 8, can't be a 9. Okay. Okay, how to continue in here? You could check for this too, so all those cells are night move away. Those are ruled out. Those, of course, also. This also. Only 2 valid options for a 2. And that's this cell and this cell to have a match for the 1. But I don't think that quite helps. Just not restricted enough. Let's just corner pencil mark them to have it in mind. That either of the, if either of those are out, we can put the other one in. Let's have a look at this 5. You need to have a 4 or a 6. Can't have a 4 in here. So the only valid option for a 4 would be here. And a 6 can sadly go in one of those 2. Okay. But this 4 may be too obvious to see, but we need a 3 or a 5. This cell can't have a 3 or a 5, so I think that's our 5. 6, 4. And this sees that. This sees that. That's not those. This one is soon to be a 7 sees that. 9, 9, 7. 7 sees 6. 5 sees 4. 8 8 sees 9. Let's pay a little bit more attention to this. Okay, the 6 needs a 7 or a 5. Doesn't have either in the marked cells, so that's, we have a 7 in here, so this is a 5, which also sees this 4. We can get rid of a few pencil marks in here. 4 and 5 here, 7 and 7 here, 6 and 6 here. We do the math later when it's narrowed down a little bit more. This 5. We have had a little look at it a few moments ago. It needs a 4. Can't have a 4 in the marked cells because this 4. So there's a 5 in this or this. This one sees this 2, can color it in. This 9 is already colored in, yeah. 6, 6. What's missing here? We're still missing a 1. Can't go here, can't go here, can't go here. So 1 in here. 5. And we got a 5, 6, 7. Not in here, not in here. So that's our 7. 6. There is a 9 miss. Let's undo that. There is the 9 missing, and that's 6 this way around. 6 sees 5, 9 sees 8, 7 sees 8. 1 does not yet have a match. 1, 2, 3, 4 in here is this or this. 5, 6. We're still missing a 6, which is here or here. And 8, which is also here or here. So that's a pair. We can get rid of the 4 and put it in here. For this 3 immediately. Oh, and now we have this one searching for a 2, which can't go here because of this one. So this needs to be this 2, and this 2 sees those ones immediately. But that doesn't mean that this 2 is invalid now. I don't think so. So but we also don't need it anymore. Let's just get rid of it. Should not be confused. Get rid of pencil marks here and here. No 2, no 7. It's narrowing down a lot. We're missing in here 4, 8, 9. We've got the 9 on top. So 9 in here, 4 in here. 1, 2, 3, 4, 5, 6, 8 also. Can't be an 8 here, so that's the 8. And that's 5, 6. Here we have a 6 on top, so 5, 6, 8. Not 5 anymore. Let's quickly check. Let's do the pencil marks for this first. 1 in here, 2, 3 in here, 4, 5, 6, 7 in here. So that's our 3. 3 already sees this one. 8 sees 9. 6. No, not really. 5. Not yet. No, no. Okay. Whoop. Sorry about that. Misclicked. Can we put a 7 in here? 7 and the lowest is 3. It's already 10. So we can't put a 7 in here. This needs to be a 1. 1 and 3, not an option. 1 and 6 is 7. 1 and 8 is 9. So that's both good. But so this is a pair. It's a 3, 4, 5, 6, 7, 8, 3, 9 pair. Okay, now it should almost work with normal Sudoku rules, right? So 2, 4, 9. Let's go down this one. Also 2, 4, 5. That's a pair. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 4, 5, 6. So 9. Yeah. Okay, that already did something. We could check again for the extra rule set. Okay, yeah. Okay, let's check for this one maybe. Needs to have a 2 in either of those, which is possible. One of those definitely is a 2. We can corner pencil mark them that again. I want to say 3, but it has like a 4 here. Oh, okay, but yeah, 3 or 5. The 5 can have this 6 too. Doesn't really help. Okay. 5. 5 needs to have a 4 or a 6. 6 here, 4 and 6 here, 4 also here. I think we're a little bit stuck now. Okay. This one. If that's an 8, we got a 7 here. If that's a 6, we need to have 5 here. If that's a 6, we have a 5, we have an 8, and 7. But I think that all looks good. Maybe let's fill in the last few pencil marks. There's one missing. 3, 4, 5, 6, 7, and 8. Not in here. 1, 2, 3, 4, 5, 6. A lot of 7. That's too much. Yeah, 2 and 2 here for the 1, 6 and 8 there for the 7. Same goes for this. 2 sees 2 ones, 4 sees only 1 3, but could be valid. 9 sees the 8. Did we check on that? We did. 1 sees 2. 2 sees 1. 1. The 4. If we put a 4 in here, where's the 5 or the 3? It can't be anywhere. So, no 4 in here. And if that's a 9, this has to be an 8. Can we do something similar with here? Like 4 digits is a lot. Oh yeah, this cannot be a 1 because it doesn't see any 2. Oh yeah, and that gives us the the 1 in here, right? Oh, but it's already seen by this. So we can get no 1 in here anymore. Does that help in any way? Those are affected by seven or eight, 7 or 9. Can't go in here or in here, right? So there's no 6 or 8 possible. So either, oh, okay, and there's no 8 possible in here. So this can't be a 9, right? Because if that's a 9, we'd have no validate option. Yeah, that's 6. 7, sorry. And 1 plus 6 equals 7. We can solve this now. 8, 7, 9. That's a 1, 7, 1. 6, 8. Okay, that helps. Oh yeah, that helped a bit. So we can check this 6 sees this 7. 4 sees 3. 8 sees 9. 7 sees 6. 7 sees 6. 8 and 9 see each other. And 6 sees this 5. This 8 is seen by that 7. And that 7 sees all of it. So that's 6. That 8 sees that 7. Okay, I think we have a great reverse here. That 9 is seen by that 8. And for this one, we're gonna find a 2 in any of those cells. Only 2 options there. Oh, that's a pair. So we have the 5 in here, which points to the 7. No 5s in here. 5 is seen by 6. 7 is seen by 8. 5 is seen by 6. This 4 needs a 5 or a 3 in here. Doesn't, but the 1 in here tells us that that's a 2. Oh, sorry about that. That's a 2. 9, 4, 2, 4. And I think now it's so. Okay, almost. Before we continue figuring out that, let's highlight those matches. Those match 2 and 1, 1 and 4. This 4. Yeah, is looking at this, but both are valid. This 4 is also looking at that. And this 6, no, the 6 has a 7 on the left hand side. So, yeah, if that's a 5, we need to have a 6, which is here. Oh, but it can be a 3 because of the 2. If that's the 5, we already got a 6, but we don't have a 2 or 3, 4. So that's a 5, that's 3, that's a 5, that's a 3 again.